You know those iconic games from the 80s? Ever wondered how they were actually made? Well, today we're going to fire up the legendary Commodore 64 and unlock the secrets of sprite programming. We'll be using Simon's Basic, which was this supercharged version of the language that, honestly, put real game creation tools into everyone's hands. So get ready, because we're about to build our very own 8-bit hero right from scratch. So how is a game hero born? I mean, how does any great character, whether it's a space marine or just a bouncing ball, actually come to life? Well, it all starts with one single, movable object on the screen. And that concept, my friends, absolutely revolutionized early video games. It's called a sprite.
All right, so here's our game plan. We're going to go through 5 steps to take us from a totally blank screen to a character you can actually interact with. We'll start with the magic of sprites. Then we'll design our character, bring it to life, make it interact with the world around it, and then it's your turn with a little programming challenge. Sound good? Okay, let's get into it.
Okay, first things first, let's really dig into what sprites are. I mean, why were they such a massive, game-changing leap forward for a machine like the Commodore 64? So the easiest way to think about them is like actors on a stage. You see, the Commodore 64 had this special graphics chip, the VIC-2 chip, and it could handle up to 8 of these sprites all on its own, completely separate from the background. This meant they could just glide right over the scenery without messing it up. And that right there was the secret sauce for making those smooth, dynamic games we all remember. All right, now for the really fun part. This is where we get to be pixel artists. Yep, we are going to create our very own character completely from scratch. Okay, before we can paint, we need a canvas, right? That's what the design command is for. It tells the computer, hey, set aside a little block of memory right here for my sprite's artwork. And it's pretty simple. We'll use design 0 for high-resolution sprites and design 1 when we want to get a bit more colorful. And this brings us to the classic dilemma every single Commodore 64 developer had to face. What do you want more of, detail or color? You see, you couldn't have both. High-resolution sprites gave you these super sharp 24-pixel wide graphics, but with only one color, perfect for really defined shapes. On the other hand, multicolor sprites, they were a bit blockier, only half the horizontal resolution, but, and this is a big but, they let you use 3 different colors, and that made your characters just pop right off the screen. So how do we actually draw? Well, meet your digital paintbrush, the @ command. To make your character, you're literally just going to write 21 lines of code, and each one is going to start with this @ symbol. Think of every line as one thin, horizontal slice of your sprite, working from the top all the way down to the bottom. It's actually pretty cool how it works. You use a simple character, like a period, to mean leave this spot transparent. And then you use a letter, like B, to say put a colored pixel right here. And just by building up these lines, layer by layer, you can draw, well, anything you can imagine. You could make a simple diamond shape like the one you see here, or you could go all out and design a super complex multicolored spaceship.
Okay, so we've designed our character. It exists. But right now, it's just sitting there in the computer's memory, totally static. That's no fun. Let's make this thing move.
In Simon's Basic, getting our sprite to move is a super simple 2-step process. First, we use a command called mobset. Think of this as getting our actor ready backstage, putting on the costume, checking its properties. Then, when it's ready, we use MMOB to send it out onto the stage.
So let's break down MOB set a little more. It's basically the pre-show checklist for your character. You have to tell it a few things. Which sprite number are we talking about? Where is its design stored in memory? What color should it be? What's its priority, like should it appear in front of or behind the background stuff? And finally, which resolution mode are we using?
And once that's all set, the director shouts, action. The MMOB command, which just stands for move mob, takes that sprite you just set up and sends it gliding smoothly across the screen. You just have to tell it which sprite to move, its starting X and Y coordinates, where it's going, and, of course, how fast you want it to get there. Now, the real power here, and you've got to understand this, is that with just one single line of code, we've created smooth, hardware-accelerated animation. This was a huge leap from standard basic. Back then, you'd have to manually calculate and poke every single position, pixel by pixel. It was slow, it was painful, and it usually ended up in a flickering mess. Okay, this is great. Our sprite is moving. But a game needs more than just movement. It needs interaction, right? Your characters can't just pass through walls and enemies like they're ghosts. So how do we make them aware of their surroundings? Well, the answer is something called collision detection. Honestly,
This is the secret ingredient that turns a simple little animation into a real game. We need a way for the computer to tell us instantly, the very moment that two objects on the screen have touched each other.
And, once again, Simon's Basic makes this a really straightforward two-step process. First, you use the detect command. This kind of arms the system. You tell it what you're looking for. Are we checking if a sprite hit another sprite, or if a sprite hit the background? Then, once it's armed, you use the check function to ask the simple question, hey, did that collision just happen?
And here's a detail from our source article that I just absolutely love. It's such a wonderfully quirky reminder of how these old systems worked. The logic is totally backwards, so you have to remember this. If the check function gives you back a 0, that means you've hit something. If it gives you a 1, the coast is clear. It's not logical, but hey, that's just how it is.
Okay, let's look at a quick example. This line of code here is checking for a collision that involves sprite number 0. So if that check function comes back with a 0, which we now know means a collision happened, then it will print crash right on the screen. And from there, you could do anything. You could stop the sprite's movement, you could play a sound, you could jump to a game over screen. I mean, this is the very foundation of game logic right here.
So there you have it. You now have the fundamental tools. You know how to create a character from scratch, you know how to make it move, and you know how to detect when it hits things. The keyboard is officially yours. It's your turn to be the programmer. So to get you started, I've got 3 little challenges for you. First, go design your own unique multicolor sprite. Really get creative with it. Second, write a program that uses MOB set and MMOB to move it from the top left corner to the bottom right. And for a bonus challenge, look up the RLOCMOB command. See if you can use it in a loop to make your sprite dance all over the screen randomly. All right, pop quiz time. Let's do a quick knowledge check and see if you were paying attention. Which command is our digital paintbrush, the one we use to define a sprite's appearance pixel by pixel? The answer is the @ command.
Okay, one more for you. Take a look at this MOB set command. What does that final number, that last 1, actually tell the computer? Well, that last part is the resolution flag. A 0 would mean high res, so this 1 is telling the computer, hey, treat this sprite as a multicolor one.
And that's it. The building blocks of so many of those classic games, they are now officially in your hands. You have the tools to create a character, make it move, and make it interact with a world. So the only limit really is your imagination. The question is, what story will you tell? Happy coding!